All right, here's a quick attempt at an explanation for 3-wire circuits. I'll make a drawing that's similar but not exactly the same as what you might see in your homework. Every time you see that symbol, it's going to be 1 amp. And then I think I'll throw in a 2 amp load there. And another couple of 1 amp loads over there. And some load that's full line-to-line voltage of about 5 amps out there. And you might have to calculate amperage out on your 240 volt load. They might give you a kind of a funky given of like a horsepower and expect you to remember 746 watts per horsepower and do a little math, and we'll talk about why that's sort of messed up, but they're just trying to get you to throw some more of your stored knowledge in there. If you see a horsepower, use 746. Then calculate some amps. The key is start out, you have something like this, it'll be labeled A phase or phase 1 and B phase, and then the common or neutral conductor. And there'll be something like, and it really wouldn't matter, it could be any voltage, it could be 12 volts and 12 volts and 24, it could be 50, 50, 100, but usually we think of it as being 120 volts, 120 volts, and then 240 volt loads from A phase to B phase. So what I would do if I were you is I'd either mentally or physically make myself a drawing, get a couple of colored pencils, and decide what direction current's flowing. Pick a half cycle. During 1 half cycle, current will be going out of A and back to B, right? A circuit. I picked some crappy colors, but I hope you get the idea of that. There's B. Current on B side is going to be brown current, and current on the A side is going to be red current. During any given half cycle, that part of the that terminal of the source is negative and this side is positive, current flows that direction. So then you start following out the currents and do the shortest paths first. Here's 1 amp. Oh, that is the wrong color. Here's some 1 amp of red current, and it's going back towards the source on the neutral. Keeping the arrowheads on that's important. Then there's going out, down through the load, back on the neutral, it's heading back towards the source. There's another red. Here comes another one. Going out, down, turn the corner, head back, head back, head back. There's also 5 amps worth of current heading out to that 240 volt load, and once it's on the other side of the load, then it's headed back towards the source that direction. On the B side, notice that this first load, the 2 amp load, is heading this direction and that direction. That means on the neutral, it's going away from the source on the neutral. That's 2 amps. There's 1 amp headed that direction, down through the load, down, turns the corner, heads back to the source. And there's another 1 amp load. Turns a corner, heads back to the source, and we got our 5 amp load. So at any given point, if I defined a point, say we'll call this point A. All I see right at A is 1 amp neutral current heading out. And if this is a corresponding B, there's the 1 amp of the line of neutral current on the 1 amp load. There's also 5 amps from the 240 volt load. So right at point B, there's 6 amps. So at any given point, just look at the lines, the colored lines you have drawn, add up whatever they add up to, and you will see what the result is. So let's create a C and a D and an E. And that's where I'm going to stop. You just keep doing the same thing, work your way back. I would draw your lines from the source out and then start doing your math from the furthest load back and just add and subtract. It'll all start making a little sense, I hope, if that's E. So at C, you have 1 amp, that 1 amp line, and 5. 5 plus 1 equals 6. At C, I've got 1 plus 1, 1 plus 1 plus 5, 7. At D, you get the net difference. 7 minus 6 is 1. There's 1 amp through that through that load going back towards the source, and there's 1 amp through this load and 1 amp of brown current through that load. There's 2 amps of brown current, 1 amp of red current, so you have a net 1 amp brown current. You can either look at the total on the line, it's the difference, or you can just look at the neutral current and do addition subtraction. Hopefully that's enough of a preview to make sense. Thanks for the question.